Hello everyone, welcome to another video. In this video we are going to solve Leetcode problem number 88, merge sorted array. So in this problem we have two arrays. So let's read the question. We are given two integer arrays num1 and num2 sorted in non-decreasing order. Means not decreasing order, means the number will be increasing, but if they have the duplicates then it will be in a the duplicates element will be adjacent to each other. And then two integers m and n representing the number of elements in nums1 and nums2 respectively. Merge nums1 and nums2 into single array sorted in non-decreasing order. The final sorted array should not be returned by a function but instead be stored inside the array nums1. To accommodate this, nums1 has a length of m plus n, where the first m elements denote the elements that should be merged and the last n elements are set to 0 and should be ignored. Nums2 has a length of n. So what is the problem is what he is asking is that nums1 has a length of m plus n, so m denotes the number of elements for nums1 only, and it has given us the extra n length to put the elements of nums2 into the nums1 and then return the nums1 array, and we have to return the sorted array. Okay, let's first see the brute force approach. So in the brute force approach, what we can do here is we can just put this element here and then sort it. So it will then the brute force solution is very straight and simple, that we can just put this element into this array and sort the array. We will get the answer. Let's try to code it. So we'll copy this question and paste here, or we can just directly try to code this problem in here only. Okay, so I solved this using JavaScript. Now we'll do using JavaScript. So what we have to do is we will first start a pointer from here, nums2 of 0, from 0 we'll start the pointer from here. We'll loop through this and put the elements one by one here. So what we'll do first is we'll just put a one pointer here and one pointer here to put the elements from here to here. So first let's take a pointer I is equals to m. So we have placed the n pointer at this position, which is m is 3, m is equals to 3. So our one pointer I is equal to I is here, so that we will loop through this array and put the element one by one here, and we'll run the for loop. We'll use the another pointer j from 0. We'll start the pointer from 0 and it will be less than n. N is the number of elements in array nums2, which is our second array, and then we'll move the pointer by 1. We'll just place nums1 of I will become nums2 of j, and then we'll move the I pointer by 1. So we got the wrong answer. Why? Okay, so so we have to sort this array also, right? So we'll just, after this, we'll just sort the array. Now we got the answer correct. Right, now let's try to submit this code. Yes, it is submitted. Right, so what to let's summarize this problem. What we did, we started a pointer at, we placed one pointer I at at m, and one pointer j at nums to from the starting element of second array, and we'll loop through it and place one element in this in this array, then we will sort the array. Right, in the and the time complexity for this will be big O of m plus n into log of m plus n, because we are having this sorting, we are performing the sorting function, so that is why the sorting takes the complexity of log m plus n log m plus n. That is why actually the overall time complexity will be n plus m plus n log m plus n, as we are as we loop through this element, as we are putting elements from nums to 1. That is why the time complexity will be n plus m plus n log m plus n, but this is the dominating factor, which is m plus n log m plus n. That is why we, so it will get n is log m plus n, m plus n log m plus n is dominating compared to n. That is why we will remove that, and the overall complexity will be this one. And that space complexity O of constant, because we are not using any extra space, we are just putting the elements into the num1. Okay, now let's see the optimal solution. So in optimal solution, what we can do is, in the optimal solution we will use 3 pointers. We will place one pointer here at m is equal at I is equal to m minus n, and the one pointer at n minus 1, and one pointer as m plus n minus 1 here. And we will check for all the elements in this, in the brute force solution. What we did, we first add the elements into the num1 and then sort the array. But here we will add the elements and sort the array at the same time. So what we will do, we will check whichever element is greater. So we'll check both the elements from nums1 and nums2. So and then whichever element is greater, we will place that element in the at the last position. So here you can see that how, let's see, understand on the paper. We will start 3 pointers, one at I, which is equal to m minus n, and the another pointer j, which is at n minus 1, and another pointer k, which is at m plus n minus 1. And we will check I and j, we will check the arr of array 1 of I. We will compare array 1 of I and array 2 of j. Whichever element is greater, we will put that element at array 1 of k. Like this we will perform the operation till all the elements of the array 2 till all the elements of the array 2 is placed into the array 1. Okay, so let's try to code this. So in this code, what we are doing here is, we are taking 3 pointers, I, which is at m minus 1, and int j is equals to n minus 1. These pointers will be used to compare the elements, and the another pointer k is equals to m plus n minus 1. It is used to place the element. So we will run the while loop here, and we will run this while loop as long as j is equal to or greater than 0. As long as j has elements, we will perform this operation. Whenever the j value becomes negative, we will get the index out of bound. Okay, so and another condition we will check here is if, Now we will compare the elements. If nums1 of I is greater than nums2 of j, we will assign nums1 of k is equals to nums1 of j I, and move the pointer I minus minus and k minus minus. Uh, so in this condition, what we are doing is we are comparing I and j, array 1 I, array 2 j. If array 1 of I is greater than j, then what we are doing, we are placing this 3 here, and then we are moving the pointer I by 1. We are moving this pointer here and this pointer here, because the value 3 is already placed here. Now again we will compare 2 and 6, whichever is greater we will place that element here. So, and in the else condition we will place nums1 of k as nums2 of j, and we'll move the j pointer by minus minus and k minus minus. That's it. So in this code, that array will already be sorted. We need not do perform any other in extra sorting operation. Okay, so I got the error of, okay, so index minus 1 out of bound. So we also have to run this operation if I is greater than or equal to 0, because if I becomes less than 0, then we'll get the index out of bound error. Now you can see we got the array sorted, and the time complexity for this code will be m plus n, because we are performing the just we are looping through both the arrays and then placing the elements. We are not doing any sorting operation, so that is why the time complexity will be big O of m plus n. So that's it guys, see you in the next video.